Alright, we're on page 2 of the 6-1 notes, continue to talk about rational expressions. What we're going to do in the next objective is to try to write rational expressions in what we call lowest terms. Again, we want to factor out any common factors until the greatest common factor of the top and bottom is 1. So let's look at this first one here. If you look at the numbers, 12 and 4, what goes into both 12 and 4? You might say, well, 4 does, right? So let's work with that first. We can take 4 into 12, so 4 goes into 4 once, into 12 3 times. So we can replace the 12 and the 4 with the 3 and a 1. Now we also have these expressions with k. So k to the 5th will go into k to the 8th, right? K to the 5th will go into k to the 5th once. K to the 5th will go into k to the 8th, k cubed times. Because k to the 5th times k cubed is equal to k to the 8th. So what are we left with here? Then we have a 3 times 1, right, which is 3, and a 1 times k cubed, which is k cubed. And so this is reduced completely, what we call in lowest terms. 3 over k cubed. We cannot take out any common factors. Let's look at the next one. So we look at the top and the bottom and say, well, can we factor anything? Well, can you cancel the y's here? No, you cannot. So you can only cancel things if you have the product of some items. Here we have a difference on top. Here we have a difference on the bottom. It's not a product. It's not multiplied. So we can't just start canceling things yet. Now, if we can factor, then maybe we can cancel. So let's see. Can we factor the top? Oh, we can factor a 7 out, right? We can factor a 7 out. We end up with y minus 5. On the bottom, can we factor anything out? We can factor a 9 out, right? And we're left with a y minus 5. So now we have the product on the top and the bottom. We have a product. And both of those products contain a factor of y minus 5. And so we can cancel that out. They basically become 1, right? Y minus 5 goes into y minus 5 one time. So we really have a 1 here and a 1 here. And we take 7 times 1, we get 7, and 9 times 1, we get 9, and then we're done. 7 and 9 don't have any common factors. So let's get to the next one. This looks a little harder, but maybe we can handle it, right? On the top, can we factor that? I think the top's not too bad, right? Again, we can't start canceling anything until we have a product of something. Okay. All right. So 2 factors of negative 54 that add up to negative 3. So 2 factors of negative 54 that add up to negative 3. So this one's a little harder, but let's think of our factors of negative 54. So 54 divided by 2, that's 27, right? Because 27 and 2 is not going to give us 3 anyway. Let's see, 54 divided by 9 gives us 6, right? So I think 9 and 6 somehow, right? So if we have an m and an m, we can probably do a 9 and a 6, and since this middle term is negative, the bigger one would probably have to be negative. So m minus 9, m plus 6, I think would probably work. Now on the bottom. So if you look at the bottom, we want to factor it. My guess is one of these factors up here is probably going to show up. This is a case where I might use guess and check rather than that technique we looked at before. Because since I'm asked to write these things in lowest terms, most likely one of these factors is going to cancel out. The 6 times something is not going to give you 27, is it? No. But 9 times something will. And so my guess is m minus 9 probably shows up down here. And so we could ask ourselves, what can we multiply m minus 9 by to get this trinomial? Well, I know negative 9 times 3 is 27, right? So that probably has to be a 3. And in order to get a 2m squared, I need m times 2m, right? So it's probably a 2m plus 3. Now let's check to make sure it works. M times 2m is 2m squared. Negative 9 times 2m is negative 18m, right? But then we're going to have plus 3m, and that will give us our negative 15m. And then negative 9 times 3 is negative 27. So we have factored successfully, and now we can cancel out the common factor of m minus 9. And we're left with m plus 6 over 2m plus 3. Now at this point some people will say, well, can I cancel the 6 and the 3? And the answer is no, you cannot. These are held together by addition. We can't cancel when we're held together by addition, only if we have a product. Okay, so this would be our answer. I like to tell people, if you start to cancel the 6 and the 3, a kitten will die. That's not true, but it gets the point across. We do not cancel unless there's a product. If we do it with a sum, we will be wrong. Okay. Now this next one is a little tricky. You might say, well, this thing on the top looks a lot like this thing on the bottom. And it is a lot like it. They're just in reverse order. Now I'm going to give you a simpler example of this exact kind of thing happening. Let's say I have something like 7 minus 10 over 10 minus 7. Now, this is a different example. It doesn't have anything to do with part D here. But it's going to get the point across as far as what we do here. So if we have something like that where the top and bottom look exactly the same, they're both differences, it's just the order is different, right? Well, what happens when this occurs? If we do 7 minus 10, we get a negative 3. 10 minus 7 is positive 3. These differences are going to be opposites of each other, which is going to cause this, it'll cancel out, cause this to become negative 1. And that's going to happen here as well. After you do a few of these, you could look at this and say, oh, this is negative 1. And that's all you'd have to do. But to show that that actually happens, what I'm going to do is factor out a negative 1 from either the top or the bottom. I think I'll do the top. So let's factor negative 1 out of the top. If we do that, it becomes negative 1 times, well, negative 4y, right? And negative 1 times positive 5x. And then we would get our 4y minus 5x. On the bottom, leave that alone. Now what do you notice here in the parentheses? We actually have the exact same item that we have down here, right? We have a 5x and a minus 4y. We could even rewrite this if we wanted to. Negative 1 times 5x minus 4y. I just rewrote this, so the order was different here. And then we have it over 5x minus 4y. And now we have the product, really, of two things on the top. We can cancel out those, and your answer is just negative 1. Technically, we have negative 1 divided by 1, which is still just negative 1. So that would be our answer on that one. So this kind of thing will occur occasionally. After you do a few of them, you might recognize this and just say, oh, I know, this is negative 1. And you might not have to go through this factoring. Alright, let's look at the next one. The top you should recognize as a difference of squares. We could write that as, if it's a difference of squares, square root of the first term is 4. So we have a 4 and a 4. Square root of the second term, x squared is x. We have an x and an x. And we should have a plus and a minus if we have a difference of squares. And then you can multiply this to verify that. 4 times 4 is 16. We have a 4x and a negative 4x, so the middle terms cancel out, and then we have a negative x squared for your last term. On the bottom, we could factor out a 2, right? 2 times x minus 4. Well, we don't have an x minus 4 up here, but we do have a 4 minus x. And remember what we can do with those? Well, 4 minus x and x minus 4, we can cancel them, but one of them has to become negative 1. And up to the side, I could show that happening. If I factor out a, well, I'll do it down here. If I factor out a negative 1 from the bottom, let's say, so we have 4 plus x, 4 minus x. I'm going to factor a negative 1 out of the bottom, so I have 2 times negative 1. This becomes a negative x and a plus 4. Well, negative x plus 4 is the same as 4 minus x, isn't it? So these cancel out. And you get 4 plus x over negative 2. And now some people may be tempted to say, well, let's cancel out the 4 and the negative 2. But again, we cannot do that because these are held together by addition on the top. So that would be as far as we could go. Alright, so the last one in this group of problems, let's see, the numbers, can we cancel anything out? What goes into both 15 and 24? Hopefully you say 3, right? 3 goes into 15 5 times, 24 8 times. So I'm going to start by saying 5 over negative 8. Let's see, we have an A and an A. Now these are already written as products, those are all multiplied together, right? So we can cancel here, A's cancel. I don't have anything. B squared will go into B cubed, B times, so we have a B here. C to the 7th will go into C to the 10th, C cubed times. And then we're done, right? We can't take anything else out of top and bottom, so that would be our answer. Okay, so that's that one, and we have one more objective on this page here. We want to find some equivalent forms. So equivalent forms, we have this negative sign in front of the fraction bar. And if you remember, with a fraction, we could actually apply that negative to the top or the bottom, and it would be equivalent. So let's apply it to the top. Negative 4x plus 3 over x minus 8. So this expression is equal to the one up above. In fact, we could distribute the negative sign, negative 4x minus 3 over x minus 8. We could also apply the negative to the bottom. 4x plus 3 over negative x minus 8. All right. So, and we could distribute that. Let's see. So we have 4x plus 3 over negative x plus 8. All right. So there we really have 4 equivalent forms, right? This guy, 1, 2, 3, 4. Those are all equal to this guy up here. Okay. There's other things we could do. So something else we could do. We could rewrite negative x plus 8 as x, or 8 minus x. And so that's just another little thing we could do. We could do 8 minus x. So there's another equivalent form. So there are a lot of equivalent forms we could have. And these are just some. So let's look at the next one. We want to find 4 equivalent forms for this expression. What I might do is factor out a negative from the bottom. So 2p minus 1. If I factor out a negative from the bottom, negative 1, we would have a negative 1 plus 4p, right? So we could do that. So negative 1 times negative 1 is the positive 1. Negative 1 times 4p is negative 4p. So that's equivalent. I could also rewrite this a little bit. If I have the negative 1, I could write it as 4p minus 1. Right? And if I wanted to, I could just change the order of those things on the bottom. So I could do 2p minus 1 over negative 4p plus 1. That's equivalent as well, right? It's just I've changed the order of the things on the bottom. So those are some things we can do. Let's factor out a negative 1 from the top. If I factor out a negative 1 from the top, I would get a negative 2p plus 1. So that's an equivalent form. I could also change the order of these two things. So I could have a negative 1 times 1 minus 2p over 1 minus 4p. So I have that. So we have plenty, right? There's 1, 2, 3, 4, 5 equivalent forms, and there are probably more. We're just asked to give 4 in this case. So, all right, that's it for this page, and we'll continue in 6.2 on the next video.